Okay, I guess I'll go first. As I said 2 weeks ago, I blew out my Itsy-Bitsy. I've now gotten I've gotten the 2 replacements and have soldered the pins onto this one so I can start or resume working with that for motor control and for battery voltage checking. One of the questions I've got for you guys is, do you put a relay in line that will shut off the batteries, or do you have a relay, or is it just a switch?
On mine, I've got just a main power switch coming off the battery. And then for the drive motor and the RC servo on the steering, I've got relays in series of those. So if I hit the e-stop switch, it kills power going to those. But then that leaves the, everything else stays powered up at that point.
And I have 3 tiers to get through. The battery management system has an on-off function that shuts off everything either going into or out of the battery management system. And then I've got a master power switch that's manual. And then for the transmission control for safety reasons, I've got power coming out of a digitally controlled relay that I only let the transmission be powered, once I'm satisfied that it's safe to send power to the transmission.
Are you using mechanical relays or solid state relays?
I just have the cheap mechanical ones. I mean, it would be nice to have the solid state ones, but it's just version 2.
And my relays are physical relays because I think it's safer to do that. You say, oh, put MOSFETs in there, but if your MOSFET shorts out or burns up, you've got problems on that. Although back to Alan's scooter project, where he used a household light switch to turn his motor on and off when he had a 90-volt battery talking to a big DC motor. And it turns out when you turn that switch off, it draws an arc, it welds that baby shut, and then you're screwed. So you got to be careful with things like that. That's why you got to look at the voltage ratings on switches, because they're fairly serious about that stuff.
The voltage or the current rating?
Well, it's the voltage that causes the problem, because if you're using DC, when you open the switch, it just draws an arc, and there's nothing to quench that arc. If you run an AC, it's constantly switching back and forth, and that'll quench the arc when you do that. But the DC just draws an arc, and it just starts welding, and then you're screwed because it welds your contacts together. So that's something, that's the first time it had come up that, anybody at Robot Shop of Horrors realized that when they say to be careful with that, that's true. Because see, a light switch in your house runs at 110 volts, which is, what's that, 100 plus or minus 100 or peak to peak, I think it's like 170 volts or something. And then RMS, it's 110 volts. And so he put the switch on his motor, which is a 90 volt DC. So, nobody expected that to be a problem because it can handle large voltages, but it turns out that AC and DC act differently. So that is something you got to be careful of.
I'll have to go back and double check what my switches are rated at, because they're not very big. But I think they're 10 amp, but I don't know that what my max draw is on these motors, what the stall current is. But I think I've got 10 amp fuses, so that should get me. Do you have just one relay for all of the motors, or Jeff, or one for each?
Well, mine, my drive motor, I just have a single drive motor that's driving a mechanical differential. So that main drive motor has a like a 40 amp automotive relay, to kill power to that. And then the giant RC servo on the front. I think I also used a 10 amp automotive relay, or excuse me, a 40 amp automotive relay, because that was what I did on the other one. So it's, and basically those two, the coils of those are just basically tied in parallel, and it goes through my e-stop circuit. So if I, say, give it the e-stop condition, both of those relays will open up, and the thing should just come to a stop.
So you have it on the, going to the normally open conductor. Okay. So
Yeah.
you close the relay, and you've always got power going to the relay when it's running.
Right. Well, I've got power going to the relay if everything's powered up and if the e-stop switch is in the run position. And then if you
Got it.
either push the e-stop, that'll open the relays and they open up and everything stops, or that for my remote control, if I send a signal from there to open up the relays, it'll do that. Or if you just simply lose power somewhere in your circuitry, then the relays open up and everything has to stop. And it's just a matter of looking at your circuit and deciding how you want it to work, and try to think all the scenarios of, is it going to get away from you or what? So that's just something you have to think about.
And what's the danger of it getting away from you? Because with my little robot, it doesn't go fast enough and doesn't have enough power to hurt anything really. But on the Snow 2, I think I probably will put that relay in.
And you're exactly right. It has to do with how big the vehicle is, how much power it has, and how fast it can go, as to, how safe does it have to be. Because you got a little thing you put on the floor that just drives around, and well, it might bang in your lamps and put marks into them or knock your lamps over, but it's not going to kill anybody. But yeah, as they get bigger, more powerful, especially if you've got a big spinning blade on the front of it, or a
Yeah.
lawnmower with a spinning blade underneath of it, you have to get very serious about it at that point.
That makes perfect sense. Okay. Because I've kind of gone back to trying to get at least the power piece and the power bus wired up and the fuses, so that I've got all of that, so I don't hopefully blow up another processor. If you remember my old robot, I've got a stainless steel sheet on it for kind of the control panel. I had forgotten how hard it is to drill that, because I'm mounting my 2 battery holders on top of that. So it's easily accessible and kind of out of the way. But I'm trying to drill a hole in this stainless steel in an area that's not supported and can't be put into a drill press. And because it's bent, it'd be a real hassle to try and take it off. So I have this piece of wood here jammed in to back it, and then I'm just slowly low speed with just a standard drill bit trying to go through. It's a slow process. That's all I really was able to get done since 2 weeks ago. I looked and did you send out an email with the link to the last week's meeting? You're on mute.
Yeah, I put up the stuff I always do. So it, said, here's the chat and here's the index and
Okay.
here's the videos. So that should.
I'll have to go look for it again. So plans for this week are to get the batteries mounted, get the power wired up, at least to the point of having it to the barrier strips that I've got. Do some more testing with the voltage divider for measuring the battery voltage. And maybe putting the Itsy-Bitsy and the associated connectors and everything onto a board and mounting that on the robot. Then the following week, I'll try and get back to ROS on Ubuntu. That's all I got.
Yeah, I did go out and look at that guy's, where you're talking about the drill batteries, and you put that thing on Reddit. And the last I looked, which was yesterday or the day before, there was no more. The other guy hadn't posted anything new on there, so he apparently does not have it figured out yet.
The last I saw, because I was gone that week, it looks like he's got kind of, here's what I'm getting and here's what it's sending, but here's how it changed from a charging versus fully charged, but not a real detailed analysis of what it is.
I saw that he posted that. He went from like discharged to charged, and then he just cut snippets and put pieces in saying, yeah, you can see the number is getting bigger or getting smaller as it charges. But if you look at it, those numbers are packed together somehow. So it's not just a number. You'd have to decode those fields and figure out what it's doing there. So because
Right.
you look down the line and it looks like it's getting bigger and bigger, and then all of a sudden it's smaller and smaller, and then all of a sudden it's bigger and bigger again. So there's some extra bits on there that would have to be stripped off to figure that out. So I'm just looking to see if he had any more figured out, and I assume since you were gone, you hadn't done anything with it.
Nope. And they don't seem to be wanting to answer that from Milwaukee's standpoint.
Yeah,
It's
I'm
proprietary.
I'm sure they won't put anything out, but somebody knows how to do it because they've got the knockoff batteries that I assume you can take somebody else's battery and put it on a Milwaukee charger, but maybe not. Maybe you're supposed to buy the knockoff battery and the knockoff charger and use those together. So I don't know what it would do if you plug those two together and see what happens. So
It seems more about using the knockoff batteries on a Milwaukee tool is where it's mainly used.
Yeah, it is, but I don't know if you then can charge that new battery with a Milwaukee
Right.
charger. So that's something that would have to be. I suppose you could ask around. People could. I'm sure other people have asked that before, and they know whether it works. And it could be that anyway. My point is they've got it figured out. Whoever built these extra batteries, they've got the thing figured out. They reverse engineered it and know what all the bits are doing.
Okay, I'm done.
You got anything, Al?
Just hopefully briefly, let's see. On the GitHub repository, I updated this a little bit. I think what's worth mentioning is the next steps are to try to figure out how to have the robot maintain speed while running a mission, finish the physical implementation, test and tune software. I also spent a little bit of time getting my embedded, what I refer to as embedded code, or the code that runs on the microcontrollers, a little bit more organized. And so there's another here, let me put that in the chat. I was I was getting confused on my own version control, and so this is helpful to say, okay, this is the most up-to-date stuff that I've got. And so one of the changes that I had to go through is this is my DIY radio control apparatus. And let me turn off blur. That's a little bit annoying. This switch is what I think Jeff refers to as a mode switch. So all the way up, the tractor is going to take commands from command velocity. In the middle, it's going to take commands from this radio control. And in the bottom is a safety deal that's going to set both the steering and throttle to 0. So it's a way to stop the tractor without hitting this kill switch, which would stop the engine. So anyway, that is what I'm currently testing. This on the screen is the tractor control sort of sun, if you will. So the ESP32 that drives this is talking to the ESP32 that's on the tractor. And at the moment, I'm trying to test the code around having it drive left and right from command velocity. And quite honestly, having a heck of a time just getting this ESP32 to subscribe to command velocity. And so literally at the moment, I have a very simple command velocity program, and I can't even, I'm still working through what libraries do I need and how do I configure my platform IO so that I can run ROS serial. So that's my challenge at the moment. And one I think interesting, if you guys haven't heard about, is it ChatGPT or GPT chat or whatever by OpenAI, I just said, hey, can you give me an example of a ROS subscribing to command velocity? And it's like, sure. And here it is. And it didn't compile. And so I asked, hey, I got this message, it didn't compile. And it said, oh, well, you've got to update your ROS headers. And I'm like, well, I'm using platform IO and running it on an ESP32 board, and it did a pretty decent job of responding with, here's how you update platform IO. So anyway, it's just an interesting sideline that can use this thing to help debug code, maybe. Still not working yet. So again, where I'm at is trying to get my radio control mode switch to be able to switch from running manual control to command velocity. And I had to redo my PID settings because I changed my previously I had an integer of -45 and 45 as my mapping values, and this plus and minus 0.73 is what I believe command velocity will generate when ultimately I get a mission running. So that's all the stuff that's in the works for me.
Where do you get the 0.73? Is that the meters per second, or?
The answer to your question is when I have RViz running and I give it a 2D nav goal, and it tries to execute that 2D nav goal, the max and min values in command velocity angular Z ends up being +73 and -73. It's driven by the variable of what's the turning radius. So if I change my turning radius in the URDF file, then that number would change. But the way it is now, I've got a turning radius of, I think, 1.5 meters, and that generates 0.73 and -0.73 command velocity statements.
Interesting.
So to specifically answer that, the 0.73, that's a steering angle for your steering. So that says you can turn plus and minus 0.73 radians, which is about plus and minus 40 degrees is what that. Instead of getting way off into command velocities and RViz, that's specifically what that is. It's the angle you're turning your front wheels back and forth.
I forget that you guys are doing that type Ackerman type steering rather than the differential, which is what I'm doing. which will be, it'll be interesting to see how much difference there is between the differential and using skid steering, which is what I'll be using on the Snow 2.
And my thought is you can just use those interchangeably, but it's just simply the skid steer is going to move your center of rotation to the center of the four wheels if you've got ideal traction. But normally you don't have ideal traction, especially since you're trying to push snow on ice. You're definitely not going to have that. So I'm going to say just basically ignore any difference between the two until you might have to later decide to do something different on it, but we'll see what happens on it.
That we will. I could used it this morning, although I probably would have needed to start doing it every hour on the hour starting yesterday.
That's all I had, Jeff, if you wanted to cover anything.
Okay, I'm not sure where to start in here, but I will say that we were looking at different ways to make your vehicle drive around and make it go where you want it to. And somewhere along the line, when ROS Agriculture started out, so one of the first things was Matt pulled up a pure pursuit planner, pure pursuit follower, and then was generating a path by hand. And let me see if I can get this other computer to talk now. Let's see if I go here and say, oh, well, Terry, I really hate computers. Let's see, how do I get my Zoom screen?
Where have I heard that before?
Zoom. Chromium, no. Zoom. Usually I have an icon for Zoom I can see, and I can't see that. So this is pictures. Okay, this back here should be. Okay, do I click on this? Participants, no, that's not what I wanted. Oh, there it is. I clicked on there's some icons at the top that. Oh, I don't know what that is. Anyway, I found my Zoom screen. Here's my share screen. Let's see if I can make this work. Select window or screen. Entire screen, I guess is what I want. And we'll see if this works. Allow what? Okay, we've got something running now. So let me try. I was going to go.
Sharing screen.
Yeah, I was going to go. What's this one? No. Let's see. Let me go make this bigger. So when ROS Agriculture started out, this is what Matt was doing. He defined a path. This is what he calls a serpentine path. Can I zoom in a little more here? This is a serpentine path. So it basically starts here at 0, 0 and drives up here to 10, 0. And then the next point you specify is the one over here. So what happens is when you run this thing, it's got a Dubin's planner in it. So going from 0 to 10, 0, this is 0, 0 down here. And up here is 10, 0. And the result of that, it just generates a straight line between those 2 points. So now if you specify this point going up and specify this point going down, the Dubin's planner will automatically generate these 3 arcs to make a loop on the end of it. And it basically is, I'll get into this in a second here. I'll show, well, in fact, we'll pull it up right now and make this bigger. So basically you create an input file that looks like this. These are your points to generate that pattern we just saw, to generate the path. You feed it into this path generator and you have to give it step size and radius. Radius is the diameter of the circles it's going to create, and step size is the fact that it breaks that big long line. It breaks it up into multiple points to make the pure pursuit happy. And then when you run it, it generates this image down here. And I probably have a bigger image of that somewhere, but for right now, it generates that. That's the same image you see on the, how do we get back to this one? That's the same, the path that you see here. So if you look at this, and I've got some links to some ROS agriculture videos where Matt was explaining this. So I'll track those down and put those in the chat in just a second here. But basically there's like kind of a yellow, or I don't know if that's yellow or white or what that is, but it puts up, this is the path that was generated by that program. And then as it drives around, this green line is the result of where the vehicle is driving. And he found figured out a clever way to do that. I don't know if he made that up or copied it from somewhere, but he's got a program. As it runs, it just takes your odometry statement that tells you your XY of where you're at, and it takes your current location and appends that onto a path file. So as you drive along, the path file gets longer and longer, and every time he updates it, he publishes that path, and then it just magically shows up on your screen here. So as it drives around, you can see that. And if I post those links, you can go watch it on the ROS Agriculture on YouTube, and you can actually watch it drive, and so you can see what it's doing. And things I noticed when I first started watching was this thing is cutting the corners here. It's not actually going out around the path like I expected it to. And after watching his videos, I could glean out all of his values that he had. So I could see his step size was set to 1 meter. So this big long line here that goes from 0 here up to 10 here, that's using 1 meter steps. So that actually creates 10 points in between there. And if I can get the demo to run, I can show you what those points look like. And then going around here, you can see there's individual segments here, because these again are 1 meter apart. So now they're going around a corner, you can actually see those, whereas you can't see it on the straight line right here. But when I just was displaying it, I found out I can turn on enough stuff so you can see those kind of things. So anyway, he was doing that. And so the very first version that he started with was doing this pure pursuit. So again, you come back to this thing where you generate this list of points in just a text file. You feed it into this program. And again, here's the step size and the radius that you have to specify. It puts out this, just puts an image on the screen, which hopefully we will see that before we're done here, see that in real time. And it also generates this point called generated points. So considering this thing puts out, say in this case, to go from 0, 0 to 10, 10, 0, it's just going to create a single path in between there, because the Dubins will just say, okay, I can draw a straight line to make that work. But then it has the extra step where it breaks that down into multiple little steps. So the step size set to 1, it's actually going to generate 10 entries. So if you come and look at the output here, so there should be 10. It turns this first thing here, where it says 0, 0 to 10, 0. It turns that into these first 10 lines here, as it's just driving in a straight line. Then as you go to turn, so the next one here, when it goes from 10, 0 to 10, 0, 0 to 10, 3, 3.14. So it's going from, it's originally going a heading of 0 and then turns 180 degrees, which is pi, which is 3.14. So it's actually, I keep wanting to say it's going to the right, but he had his stuff rotated. So we'll go with that concept if we look at this one. So starting off at 0, 0 down here. See, normally you should have it. So if you're trying to go from 0 to 10, it should be going off to the right like this. And just to make mine match his stuff for demonstration purposes, I just rotated my screen. So technically it's the whole thing should be rotated. And again, we can look at that later. So basically what it's doing is going from 0, 0 to 10, 0. It creates 10 points for that. And then when it tries to go around here, it's generating three arcs in order to do that. So Dubins will say it generates a little arc here, and then it generates a big arc around here, and then a small arc here to line you back up. So that's putting out three segments, and then each segment is broken down into probably, again, the 1 meter steps. So the thing, it expands it and gets a lot bigger. I think I decided that if we go look at this file again, So this is what about like 12 to 15 lines you're putting into the thing. And I think it generated 137 lines or points coming out of the thing. And I decided I like my resolution finer than what he has. So instead of 1 meter steps, I went to 0.2 meter steps. So I've got 5 times as many points. So again, that's going to be what, 500 and some points that it's going to generate to do this whole thing. So back to the comment about how this stuff works. This is a predefined path. So if we look at the thing here, so starting at 0, 0, you define 0, 0, you define this point, you define this point, you define this point, and this one, and so forth until you get around to the point where you define this point here, and then from here you define back to 0, 0, 0, which there's another problem there, but I fixed it. But for the moment, we'll go with that. So you're going from this point back to 0 point. So that's what's in that list of numbers here. That's all these numbers in this thing right here. And then it generates this file, which I think I decided was 137 lines long. And so that's just a text file. And this is not under ROS. This just simply is a Python program that runs right now. So we'll say it's an experimental way to make this stuff work. So it's not, you don't just click on the screen and say drive there and have it automatically generate all this stuff. You go out and purposely define the path you want the thing to drive on. So then once you get the generated points file, now under well, let's go to the bottom down here. So when you load up your either gazebo or your real vehicle, and then you start up the pure pursuit follower program, which is a ROS node, and you start it up and it'll just sit there waiting for this drive path topic to be published. So it'll just sit there forever until you do that. And once you publish that topic, it will then, if you're watching on RViz, you'll see the path will show up on the screen, the vehicle will start moving. And if you're doing something to track the position, I'm using odometry to track it right now, or I could use Matt's thing that says odom to path to get that cute green line that he had. So there's 2 ways you can watch it running. So anyway, it'll start the path, it'll drive all the way around to 0, 0. The vehicle will come to a stop, and then it's going to sit there idle again. And just a note looking forward, it doesn't stop publishing the command velocity and Ackerman command when you come to a stop. And that's a problem when I'm going to suggest we run this in parallel with move base and tab planner, because you can't have them both publishing at the same time. But I think if I go in and hack on pure pursuit and say stop publishing the data, as if you're not moving, don't publish the data, then you should just be able to go over to the move base. So you can just go to RViz and say drive to this 2D nav goal, and it should, just like it works there, it should be able to drive over there and come to a stop. So you can use that to position yourself in order, when you go to run this pre-packaged path, you can drive over there by using the tab planner to get over there. And in fact, when I was going through the ROS agriculture videos, let's see, how can I do this? And maybe I won't put it in chat right now because I've got too many computers running and I can't tell what I'm doing here. So let's see, what was the point? Blah, blah, blah. So I was watching the ROS agriculture videos, and Matt said something about, well, on the first version, it uses pure pursuit. And we were thinking about running pure pursuit and move base and tab planner at the same time. And his comment was, because you have to get your vehicle from where it's parked out to the field where you want to do the work, so you can use the tab planner to do that. And once you're out there, then you can turn it over and give it this predefined path and then let it do that whole thing. So that's something we can look at. So anyway, as I say, the pure pursuit just sits there waiting for something to happen. So then you have to go in and you have to run this program that's a path publisher, and it's actually a ROS node. So I just go in and say execute this. It goes out and grabs the generated points file, loads it in, and then builds a message, and it's going to publish at a drive path. So it's going to take, it basically just takes all these points and builds up this path message. So the path message has a header, and then it's got the I think it's called the pose section. So for each point that's listed over here in the text, it's going to generate one pose entry for that. So that, again, this path, if you look at the text file, it gets really big by the time it comes out, but that's just the way ROS works. So essentially once the pure pursuit is started up down here waiting for something to happen, and then if I execute this one, it then publishes a path, starts driving, and when it gets to the end, it just comes to a stop. So that's the concept of how I'm doing it right now. So let's go back and look at, let's see, go back here. So as I say, this is what Matt's stuff looked like. And this is actually a video that runs. If you go watch those things that I haven't posted yet, you can actually watch it. You can see it driving around as it goes around the corner. You can see how it goes around the corner. And when I was first watching that, gee, it's odd that it's cutting corners like that. But by watching his video, as I say, I could tell that his spacing, because the easiest way, as the thing's over here coming back down like this and is driving through this grid, this is a standard 1 meter grid. Yes.
Is there a way of, I'm assuming that if let's say we're cultivating, that during your turn, you don't really want the cultivator down. So is there a way during that path planning to tell it to raise the cultivator?
I would say the way it's written right now, no, but that could be added on. And on the Ag Open GPS stuff, where they're doing full size farm tractors and they're writing stuff in C++. No, is it C++? They're using Visual Studio under Microsoft and writing all this stuff. And they've got a name for that. I can't think what that is, but it's basically you can say, just create an imaginary line across here. And then say, as you're driving this way, as you cross that line, you can activate, whatever you want to do. If you want to raise an implement, or another thing, you might want to slow down when you get to that point. So they've got a way to, they can program in that. So you can just pick different points and say, as you cross this imaginary line here, the vehicle might slow down and raise the implement. You go around the thing here. When you come back to that line and get lined up, you start going straight again. You cross that line again, and it drops the implement down into the ground, starts pulling again. So that's something that could be added on top of this. And I'm going to eventually make the argument that rather than building this entire path like it's done here, I would probably just do it a segment at a time. And that way, say you're down here at 0, I would say, okay, drive to this point. And that's one segment. I turn over, let it start driving there. And then when you get to this point, say, okay, plan the next one. And so that would be a logical place to interject this thing you're talking about, where you say, do something besides just driving. So that would be a place to put that.
Because in my scenario, once I reach that 0-10, I would want to go back in the reverse direction with the brush raised back to 0-0. Then, or actually to -1 or 0-1, then move over some interval, lower the brush, because I always want to be pushing it in one direction.
Have you given any thought to, are you talking about a rotating brush? You're talking about like a paddle, like on a snowblower, or
at this point, it would be either a rotating paddle or brush that's counter rotating.
Yeah, once you start running this, then you can decide if you really have to lift it or not. It could be you can just back up and let that continue running on the ground while you're doing that. But I guess you don't know until you try it, if that's going to work or not. So, but yeah, that's something else that would have to be put in there. And then you mentioned backing up. I was just thinking about this, considering the snow outside that I've been playing with, and the fact I was thinking about your driveway, and they made some comment on the Pure Pursuit. It says, oh, by the way, this doesn't work well backing up. So that's the concept of, you could use the Pure Pursuit to drive forward and have it, follow your exact path where you want it to go. And then simply, instead of using Pure Pursuit, just use something else and just blatantly say back up. So there might be a way to, we could either modify this Pure Pursuit to work as you're backing up, or just blatantly ignore it and just back straight up as close as we think we can to get there. So that's going to come into where I start talking about, trying to use different planners together and switching on the fly from one kind to another. So we'll see how that works out. But yes, that's something that's going to have to be figured out.
Okay. And that's in Python, right? What you're currently using.
This pure pursuit, I think, is in C++, but it doesn't really matter what it's in. It's just that, it's an off the shelf node that runs. And if you want to modify it, you can just go in and hack on it and do what you need to do. So, and then as far as, switching from one type of planner, say switching from pure pursuit back to the TEB planner, which is another, that's part of the whole normal, I'm going to call it the normal ROS way of doing things. I think you can switch back and forth on the fly, but there needs to be some kind of handshake saying, is the pure pursuit running? If it is, then don't try to control it with something else. And then when it gets to the end and stops, then say, it needs to have some kind of status to say I'm done. And then when you go to run the TEB planner, you say, okay, the pure pursuit is done. So I can now specify a point for the TEB planner. So that's just more stuff that's going to have to be worked out and work through some scenarios to figure that out.
Okay.
So, looking forward, yeah, that stuff's going to have to be figured out. And the other thing that occurred to me after I was out shoveling the snow this morning, I was thinking that what I should do is create a, like Al has done. He took a aerial photograph of his property and put some stuff on there, put his house and then put some obstacles like hedges or trees or whatever they were on there. And I was thinking I should do that, but I would probably put that directly into Gazebo. And then I suppose you could put it in Gazebo and then just copy the same thing over to RViz, or you could put it into Gazebo and then drive around with the SLAM and actually build a map directly off the Gazebo. But either way should work on that. But Al's getting half of what he needs right now, because if he says go into his TEB planner or go into RViz and say move to this 2D nav goal, and say he's on one side of the house, he wants to move to the other side of the house. If he says go to that location, RViz tells the nav tells move base to go there. So the global planner fires up and it uses the map and actually plots a path around the house, but his Gazebo doesn't know there's a house there. So if you put that map into Gazebo, there you're going to have to actually have like walls sticking up. You can't just put, black lines. But if you're doing that and then use the simulated laser scanner, it will know that house is there, and it'll not run into it. So that's just more little details that'll come up as we do this. But so anyway, I was thinking about taking a photograph, taking the aerial photograph of my place and then building a map. And I figured, well, then because without knowing what you actually want to do with this stuff, it's hard to define, where do we go from here? How do I make this stuff work? So I thought if I had a plot of my property and then go through two scenarios and say, well, number one, I want to figure out how to blow snow on the sidewalk, or during the summer, I want to mow grass. So essentially one of them, you're trying to stay off the grass, the other one, you're trying to stay on the grass. So that's two different scenarios for that. And that would be a way to plan, and decide, do you want to use, physical hard-coded paths like this, or do you want to come up with some other way? As the thing drives around, it uses the laser scanner to see where the wall is and follow along the wall and all that kind of stuff. But it just seems like one of the next steps I would have to do is, come up with a world that represents something. And it doesn't really have to be my property. I can just make up a world and say, this is what my stuff looks like. So that would be a way to go there. So let's see. Now I forgot what I was talking about. I was watching Matt's video, and as they say, when the thing's driving around, wrong computer. So as the vehicle is right here driving this direction, when it gets into this grid here, which is a standard 1 meter grid, you can see that his segments, his actual segments are broken up into 1 meter long. And then you got the other concept on pure pursuit. It puts a marker out in front of the vehicle, and the thing is trying to control to that marker. And again, if you go watch the YouTube videos, you can watch that happening. Or if you watch my videos, or my demo, we should be able to see that happening. So I looked at that, and it looked like at the time he's running a 2 meter look ahead, which means from his base link out in front of the vehicle, it puts a point on this line 2 meters ahead of where you are. And it turns out that look ahead is very related to your speed. So if you're driving slow, you can move that look ahead back closer to the front of the vehicle, and it'll track very closely on the line. But you start speeding up, it starts getting wonky and wobbling around on the line. So if you move that look ahead out, so I was able to run mine at 2 meters per second, and if I put a 2 meter look ahead, so it's looking at 2 meters in front of the vehicle and controlling to that. And I decided 2 meters per second is pretty fast. Mine won't do, my real vehicle won't do that anyway. I was planning on running my real vehicle at 1 meter per second maximum. And so if I put my values in and say, I want the speed to be 1 meter per second and set the look ahead to 1 meter out in front of the vehicle, it seems to control very well on that. So other things I noticed from watching Matt stuff, I can't immediately tell what his forward velocity is. I suppose just by watching the grid as it goes across the grid and estimating how quickly it's doing that, I could probably guess at what speed he's running. And then the other thing was, so it was what, so you got the look ahead, you got the step size that breaks this line up into, and then the loops out here. If by again looking at it on the grid, it looks like that's a 4 meter diameter loop that he's doing. So you have to go in and tell it that's a 2 meter radius to get this stuff to work. So by taking his numbers, and I finally found that list of numbers, this one here. I found this actual wrong one. I thought this one is out on anywhere you find in the repositories where he's talking about doing the generated points stuff. And I'll tell you another story on it in a second. But anyway, this is available out under those repositories. And the only wonky thing is down here. He wants to come back to 000, but he found out that doesn't work. If you put 000, it'll never execute that line. And it took me hours to figure out why. And it turns out it's the way Python works, and whoever wrote the program was assuming that when you start up, it says, oh, if the first entry matches 000, we'll set that, we'll preload that as our initial position. But what happens is when it comes down here, if you have the last one that says 000, it thinks that's an initial position and it won't execute that. So I put a loop counter in there that said, if the loop counter is 0, then we'll assume whatever the first value is, whether it's 000 or something else, we'll assume that's the initial point, and everything else then is considered normal points. So you can come down here and we could change that back to 000. And I'll show you when we pull this up and run it. Actually, we can see it right now. It's a little bit hard to see, but nah, you can't really tell here. When I pull up mine, it's more obvious that as the line comes back around, it doesn't hit 0. It actually it's somewhere off the line here. And it turns out that's not a big problem, which, well, we'll get into that later too. So anyway, that I was able to glean the stuff out of watching his video running and listening to his descriptions to decide that, yes, I can make this probably do what I want it to. So then I did some experiments. No, wrong way. This is one of the first experiments I was doing. Let's see, I can make that bigger, right? And basically, I just have the vehicle sitting here. Here's this point right here is the 0 point, and you can tell by looking at the grid, that's the center of the grid. So that's your 0 on. In this case, we're in RViz, and then it's pointing to the right because when I start up either RViz or Gazebo, I rotate it so the red marker is pointing to the right. So the red marker is pointing east, and that's your x-axis, and that's the way ROS wants to see it. And then when I run mat stuff, I have to rotate everything by 90 degrees just so the maps look the same. So anyway, this is one of the first things I was playing with, and I start the vehicle there. It will then drive around, and you can actually see this right here. This right here is the look ahead marker. So as it drives around, you'll see that out in front of the vehicle, and you can watch to see what that's doing. Basically, the vehicle is trying to drive to that point all the time. So anyway, that was this is one of the first things I did. And speaking about maps and obstacles and RViz and gazebo, this red line out here, I have a out in gazebo, I have a just grabbed somebody's arbitrary world and it has this fence. So it's like a big arena. If you're going to put people in there to fight in this arena, or like like bullfighting where you have this big round pen. Basically, it's just a wall that's round. And I had to be careful because if I tried to drive too far, I'd slam into this wall. And at one point I was getting real close. Oh, it's almost going to hit that, because if I hit that wall, it does affect, being a physics model, it does affect your vehicle and screw everything up. So later on, I finally just, number one, I pulled this back to make it shorter so it would fit inside of the wall. And then the other thing I did later, I just blatantly loaded an empty world so I don't have that wall that I have to worry about running into. So then the next one is, this is the vehicle driving. So I simply turned on the odometry markers. So as it drives along, it leaves an arrow behind. So the base of the arrow, let's see, can I see one here? See right here, this is the base of the arrow, and that's supposed to be on the line. But when I started off, it wasn't pointed exactly, wasn't exactly right. For some reason, my vehicle drifts around. If you start up gazebo and let it sit there, the vehicle kind of rotates, and sometimes it kind of slowly backs up. But as soon as you start the pure pursuit, it will get back on the line, and that's what it was doing right there. So it might have been sitting in this position, and when I ran it, see there's the base of one right there that's not on the line. Here's a base of another one that's on the line, and then by the time it gets over here, the base of that arrow is getting closer to that line. And again, as we watch live demos, you can see that. But as it drives around, you start it up. And see, it was sitting right here. It starts up, it goes this way and comes around the circle like this. And you can see mine is much closer to the path than what Matt was doing. And you can go and you can play with several parameters to control how well that works. So right here, it's kind of cutting the line there. That's kind of cutting the line right there. But coming around here, it's fairly close on the circle. And if I had a big long line here, it stays fairly close. So it comes all the way around like this, and when it gets back to here, it just shuts the thing down, says load in a velocity of 0 and a steering of 0, and the thing will coast to a stop. So that was what I was doing. And I thought, well, then I was tracking down the path that Matt had, so I created that one. So I took his path like this, and I found I found this list of points here. So I used that list of points, and then what I was able to decipher from his video, I put that in for step size and radius and look ahead and all that kind of stuff. And back to this screen. So if you watch this one, you can see his is cutting the loop pretty tight there. And I'm not sure if that's something because of steering on his vehicle. This was also running under the stage simulator. So this was not under gazebo like I have. So it could be that there's something funny there about the way it's translating that. So then mine, I came up, and when I run mine, it puts this green line is so as soon as you start it, it pops this green line on the screen, so that shows up immediately. And then the vehicle is sitting here pointed up. And as soon as it starts moving, you'll see that the look ahead marker will be out in front of the vehicle, and it'll start driving, and it looks like it's staying right on the line most of the time. And then when it gets up here, going around the corner, again, it's cutting the line a little bit right there and a little bit right there. Actually, I don't know that it is. It's these lines, these arrows are a little bit deceptive. And again, the resolution is pretty bad here. But what you're really looking at, you're looking at the base of the arrow. Is that staying on the green line? So then on one of the videos for ROS Agriculture, Matt says, well, here's what my stuff looks like. And immediately Al typed in, but what's your cross-track error? So Matt looks down his chat and says, oh, cross-track error. Well, on his, he has this other thing. And he explains that on one of those videos. He's got this text box here that's on the screen. And there's like 3 steps to get that text box on there. But as you drive around, this is plotting your cross-track error, saying how far are you off the line. And I got several steps of it figured out, and finally last night I said that's got to be generated somewhere. And I went out and looked in the modified pure pursuit that Matt and Juan were using, and sure enough, in that code, he's putting out this this error, and it's basically it's making the assumption if you're driving in the X direction, that's staying on the line, so it just takes the Y component of that, and that says how far off the line you are, and publishes that as something called off path error or something like that. And so you just got a topic that's telling you how far off the line you are. And then there's a Python script that runs that subscribes to that and republishes that as whatever it is that RViz wants to see. And to get this to work in RViz, probably you can't, this resolution's so bad, but I think it's this one right here. Yeah, right there. It says off path display. So Pure Pursuit publishes one thing, the Python script converts that into this off path display and publishes that. And now in RViz, you add a plugin. I can't even see what that's called. It doesn't matter what that's called. It goes out to somebody's library of cute little things for RViz, and you say load that, and it creates this text box on the screen. And then so you got this text box on the screen, and it gets its value from this topic that's specified right here. So it takes several steps to do that, but once it's running, then apparently that number one, it puts a number up there, and then secondly, it's like a little oscilloscope display. So as it drives around, you can see it, doing little things like this. So that gives you a graphical representation and a number while the thing's running. So that is available, and I think I've got that figured out, but I haven't actually gone through the steps to actually make that work yet. So on mine, as just by visually looking at mine looks like it's tracking pretty close right there. Let's see, I can zoom in like this, right? So I started off at 0, 0. I was saying that the path is something weird. Here you can see that this line right here is the 0 line, and then when it's done, it comes back to that minus 0.1. So he's off by this far just to get around the fact that program was throwing out the last line. So by putting this line, he could have put in like 0.0001, and it would have effectively been 0, and that would have got around the bug in the program. But anyway, that we'll see when we run it. It gets to this point, the vehicle just stops and coasts forward a ways, and kind of for some reason it drifts off in this direction, but that's what it does. So another thing that came up was, I thought, well, but if you have a predefined path that you're starting at 0, 0, 0, that means your vehicle has to be sitting here in the proper location before you start it. I thought, wow, that's going to be
and the proper orientation, right?
And the proper orientation. So I thought, well, what happens if you're not in that location? So like say right here, if it's coming around, I do Control C on the Pure Pursuit, the vehicle will stop right there. And if I say run it again, it will just automatically do a really hard turn either this way or this way. And it does a more or less straight line heading for this 0, 0 point. And once it gets close to that, then the Pure Pursuit starts up, and then you get your follower marker starts going this way, and the vehicle just, say you're coming in like this, it'll just drag itself in until it lines up and starts controlling. So that means you don't have to put the vehicle in the right spot. It's just that if you're up here and it does that, say if the vehicle's sitting right here and you start it up, the vehicle, see in this case, I'd be going up and I stop right there. So you start it up, it's going to do a really hard turn like this and start heading towards 0. And it's not a really straight line, because I don't know why it's doing that, but that's what it does. It gets right about here, and when it hits like 0, then it does another really hard turn, and right about here the Pure Pursuit kicks in, and it starts pulling itself in and gets on the line, and then away it goes. So theoretically, you don't have to do anything extra. You can just just running Pure Pursuit, and you got this thing sitting out in the yard while you drive so far and say, I want it to stop now, and want to run it again. You just say fire off the path, and it will somehow it magically figures out how to get back to where the start point is and takes care of itself. Because otherwise, if it wouldn't do that, it'd be a real pain, because you'd have to painstakingly position the thing every time you go to start it, and that would waste a lot of time of just playing around. So that's something else I noticed as I was playing with this. other things of interest right now. Over here, I've got 3 windows open. The bottom window is the Ackerman command that's putting out. So here, steering angle, it's currently, as it's going around that big loop right there, it says minus 0.24 radians for the steering angle. And the speed is 1 meter per second. And make note on this as I go to run this demo. Watch to see, does the speed change? I think if you say 1 meter per second, I think whether it's going straight or going around the curves, I think it's going to maintain that same speed. And what was the other thing I wanted to find out? As soon as I start the pure pursuit, I want to know, is it publishing immediately on these? Because I've never looked at that, but if I drive around all the way and it comes to a stop, then the command velocity and the Ackerman command are both putting out 0. Say 0 velocity and 0 steer angle or 0 rotational angle. 0 rotational velocity. Or so once it comes to a stop, it's publishing that, and it never stops publishing that, which means that will interfere if I try to run move base and tab planner at the same time. So I'll have to go into the code and say, once you come to a stop publishing these messages, and then I should just be able to fire it up and run, interchangeably one or the other, and make it work. Again, as an experiment, because eventually you have to figure out the handshake to get this stuff to know whether it's still moving or not. And because you can't start the other one moving if the first one's moving. So that's 2 things. I can go do this on my own time, but as I start up pure pursuit, when I say now I'm going to start pure pursuit, and if I got these boxes running on the right, just notice if because they won't, it'll say this hasn't been published yet. And as soon as I start pure pursuit, I assume these will immediately both pop up and say 0, 0 on both of them. So that's one thing to watch for. And the other thing is, as it drives around the loop, I want to know if this velocity is changing. So is the velocity the same on the straight as opposed to the curve? And in the future, you could probably say, let's see, where's I don't think I have anything really here to look at, but say the vehicle's coming up here. Say the vehicle's coming up here in a straight line, and the look ahead marker's out in front. You could just simply say, what's the angle from the vehicle to the look ahead marker? And as soon as that becomes non-zero, you can start slowing the vehicle down. So you're coming up here and say at 2 meters driving along, and you get right about here, the look ahead marker would be out here somewhere, and see you've got a non-zero angle there. So it'd say, oh, I can see there's a curve coming up. So at that point, you could drop it down to say 1 meter per second or 0.5 meter per second. So then they will drive around here at a slower speed, and you get right here. Well, at this point, so the vehicle's sitting right here, and the look ahead marker's out here. Well, it's on a straight line, but you still got an angle between where the 2 are. So the vehicle itself has to get all the way out. As soon as the vehicle gets onto the straight part right there, and the look ahead markers down here, you got an angle of 0. So now I can speed back up to whatever the fast speed is. So that's something else that maybe could be modified at some point to make it do that. If people want to do that. It just seems like if you're going around a circle, number one, you probably get better control if you slow the vehicle down while it's doing that. And 2, as standing out in your yard and not knowing what the vehicle is going to do can be very scary. So if it comes up to a curve like that and it's coming along at a fast speed and then slows down for the curve, you got a much better chance of deciding, is it doing the right thing or not? So that's just more things we can look at. So I think I'm running out of things to just blatantly talk about here. So let's see if we can fire up a demo here. So let's say, what's this here? Get rid of that. Get rid of that. Let's see. I'm still screen sharing, right? Yes, I am. Get rid of that. So there again, they're just the text file that has the waypoints in it, and then the generated points looks like this. And if I go clear to the end, this I think is set up for Matt's numbers, so it's probably got I was going to say it's got 137 lines. I think it says 137 is the last line in there. So it generates 137 points out of that initial waypoint file. So let's see, do we need to look at anything else here? Let's just jump right into it. So on this screen, I like to start up a ROS core just so as I start and stop things, it's not, I don't have to worry about it, my ROS disappearing on me. So I'll start up ROS core there. Come on. That's what I'm talking about. Everything's getting slower and slower as I do this. And I don't know if I'm going to eventually have to reload my Linux, or if it's just, you know, usually if I restart my computer, it comes back mostly. Okay, so ROS core is coming up. So I now have a valid ROS core. So if I come down here, this is the command velocity message. This one is the Ackermann message. And you'll notice they're both going to say does not appear to be published yet, because there's nothing generating these messages. And then just for kicks, here's the this is the IMU data coming from the simulated IMU on Gazebo, and I'm just displaying the rotational velocity section out of that. So if you look at this, the Z field on that tells you the current rotational velocity that Gazebo thinks it's moving. Whereas this command velocity here, this is a requested rotational velocity put out. Now, I'm not using this command velocity, but for some reason he's publishing both of these, which is actually kind of a clever idea, because then you don't have to worry about converting from one to the other. So it publishes this command velocity message, and it publishes this Ackermann message down here. So you just use whichever one you want. So like in Terry's case, if he's trying to run this, he'd probably just want a direct command velocity to run. So you don't have to translate all this stuff back and forth. That could go into another story, but I'm going to not do that right now. So I'll fire up the IMU, and it says it's not published yet. So let's see what's this one. So I'll run this one just so you can see what it does. This is the path planner that takes the list of waypoints and converts that into the generated points. And with any luck, it'll give me, okay, there's my image. So it directly puts this out. That's what it created from that list that I just gave it. And I can tell by just looking at it, see, it's got the choppy circle out here. So I know it's got the 1 meter step size. And by looking at it, you can also tell from this row to this row. This is what I noticed on Matt's stuff by looking at it. From this row to this row is 3 meters apart. It's probably easier to look down here where this is 1 meter up. Well, actually, here, this line's at 0, and this is at 3 by looking at the graph. So he's got 3 meter row spacing, and you can tell the diameter of these is 4 meter diameter, which means you need a 2 meter radius. And that's about how much I could figure out by looking at Matt's video that he had. And so I can't tell what his velocity was, but as I say, I could probably, you know, estimate what he was running on that. So let's see if I just minimize this, because I might want to come back to it. And so that's running. So now I start up this one, which is to start Gazebo. So you notice at this point, the command velocity and the Ackermann on the right have not updated yet. So there's nothing publishing those. So when I say now I'm going to start pure pursuit, that's when we have to start watching those and see if they immediately start publishing. Now, as soon as Gazebo starts, the top one over here, the IMU, will start spitting out data, because it has nothing to do with your planners or anything. It's just simply saying, going out to Gazebo and say, what is my current IMU values? Oh, this is going to take forever because I didn't hit return after I did that, or enter. There we go. Now it should come up quicker. I say this meeting is going to be pretty long today. Okay, we're getting closer. I think those red messages that scroll by are simply saying Ackermann vehicle has not been published yet or created yet. So let's see. So here is the Gazebo window, and I don't need any of this stuff over here, so I make that smaller. And I usually make this to a size I can see. So you'll notice on the right, the IMU data is now active. And here's what I was talking about before. See, it comes up at about a 45-degree angle. So I like to come in here and rotate this thing around like this. So this is the way you would normally see the vehicle. So the red line points to the right, which is east. So a heading of 0 degrees is to the east, the way ROS decided to do everything. And you can't see it right now, but the green line goes up this way. Yeah, there you can see it. So the green line is following this grid line, and the red line is following this grid line, and the blue line is pointed straight up. So if I come in here and do like, let's see, how do I do this? And it doesn't really matter what I do here, because as soon as I get it running, I'm just going to turn this, hide the screen anyway. But that's just showing my vehicle. Now you'll notice here, it's already started. It seems to be rotating like around this point right here. The back end is starting to rotate around. And if I pull up my odometry message, which is just another thing that Gazebo is putting out. See, if you watch here, the X and Y values, see, it looks like the X value is moving a little bit. And if I look at the, here's the speeds down here. So it says, it thinks it's moving forward at 0.002 meters per second, which it's not supposed to be. Nothing's telling it to do that. And see over here, the commands, the command velocity and the Ackerman command are still both at 0 right now. In fact, they're not even being published right now. So there's just something funny with the Gazebo that it's, I'll have to track that down and see what it's doing. And see, it also says it's rotating slightly. And that's why if we come back over and look at the Gazebo screen, see it's rotated a little bit more now. It's not, you can see the vehicle's not lined up on this red line anymore. But it turns out that's not really a problem. So anyway, I'm just going to hide this window. Well, do I want to hide it? Let's just put it over here. It's kind of cute to see it. So you see it driving in the background, just so you know it's really doing something. So I'll do that. So now, as I say, I think I'm about to fire up Pure Pursuit. So we'll watch those windows. Now we're going to fire up RViz instead, I guess. So normally in RViz, let's see, there's a lot of stuff not showing up over here. It says I got a lot of broken links, and that's simply because I'm not publishing any. The Pure Pursuit hasn't started publishing stuff yet. So now here's these two windows, and now I'm going to start up Pure Pursuit. Let's see, how can I do that? I can do like this, so we can see both these windows are here. And I think this is the RViz window. Yes. So I come to this one. Now I'm going to start a Pure Pursuit. So when I do, watch those two boxes on the side there. And see, they immediately start publishing both command velocity and Ackerman angle. So I need to go in there and say, if you're not currently moving on a path, don't publish those. And then I should be able to run this at the same time I'm running move base and tab planner. So anyway, back to my RViz. Now, if you look here, you can see the vehicle has, let's see, which button do I want? You can see the vehicle is rotated enough. This green line is saying that that's the map and ODOM a marker sitting at 0, and see the green line is lined up this way, and you can't see it, but the red line here, if I turn off robot model, I can see that robot model. So you can see that the robot has rotated by some amount, I don't know what, 5 to 10 degrees from the actual where it's supposed to be. Now, typically this again, as I was saying, normally what I do is come into RViz and do this. This is the correct orientation that's supposed to have, where red is pointing to the right. So that means red is X and X is pointing to the right, which is east, and that's 0 degrees. So that's the way it's supposed to be. But to make a match stuff right now, I just leave it like this, so that the two views will look the same. So anyway, there's the turn my robot model back on. And move this. Let's see, which button is it? This one? Yes. Okay, so now what we're about to do, you can see the Gazebo just hiding in the background here. I could just minimize this completely because I don't really care about it after this. So what I'm going to do is now I'm going to start up and say publish a path, and you'll notice a couple of things. Number one, you'll notice that it will then splatter that path all over the screen here. So you'll see that. That's where it wants to drive, and that'll be a green line. And then once the vehicle starts moving, is my odometry turned on? Yes, it is. So as the vehicle starts moving, it's going to leave little arrows behind just so you can see where it has gone. And as soon as it starts moving, you should see both over here. Here's that speed thing we want to watch for. See, the X velocity here says 0 and the speed down here says 0. As soon as I start it, I think those are set to 1 meter per second. So those will go to 1 meter per second and the thing will start driving around. So that's what we're about to see here. So I'm going to click on this. Bang, there's our path. And see out in front, you can see here's the marker. This is the look ahead marker that's going out in front. And you can see the speed's at 1 meter per second. We're approaching the curve here. And it does not slow down. So there's no actual speed control in this thing, but that's something that can be added. So as it comes around the corner, you can see the transform marker. I think it's set to 2 meters right now. I think the speed is set to 1 meter. And I think see right here, you can see this thing is jumping ahead by 1 meter at a time. And let's see, how do I do that? Path. I found out a way in here. I'm going to drive path and say pose style. And if I say arrows, no axes, yeah, we'll say arrows. Huh. Why did that? Well, and I'll leave that turned on. Next time we run it, you'll see those arrows, and the arrows will then indicate, it'll show you, it's like in Excel where you say, I want to plot a line, or do I want to plot a line with points? So as you do with points, the other thing I'm noticing here, there's more of a curve here than there is over here. Here it's just more just a straight line coming back down. But I have not adjusted the parameters away from what Matt had. This is Matt's numbers running right here. But let's see, how do I get the path to come back? Here, I'll show you this one too. So I say, go to this one, do a Control C to stop it. Now, if do I want to erase that or not? Let's erase that. So I say display path. No, it's ODOM. Erase ODOM. So ODOM is going to display. Drive path should display. And now if I say, see, I'm not going to reposition it back to 0. I'm just going to start it running again. And over here, you can't tell right now, but I believe, well, command velocity and angular command are not publishing because I killed the program. So we can't really learn anything from that. So I'll run it again. And the path should show up about now. Why didn't it run? Oh, I just started pure pursuit. I haven't published a path yet. So I'll say publish a path. And the path just runs once. So see here's like in Excel, I've now got points on my line, so you can see how far apart the spacing is on that. And you notice it did a hard turn and it's heading right for 0. I think it's going to overshoot and come back around like this. So there, bang, there, the pure pursuit just started, and it actually started early. So see, you don't have to be at the point to start, but you're going to miss the point. So you could actually, for testing, actually define your point down here. So if you want to go through 0, 0 straight, you could either put that so it comes down, it's gonna be lined up before it hits 0, 0. Or if you got the tab planner running, we could go in and say, go to 0, 0 pointed that way, and it should position it correctly. So again, as I say, you can see it's not tracking exactly up here. And now I turn on those arrows, you can see the points on the line that they're 1 meter apart. And you can see the look ahead is about 2 meters ahead, and it's jumping ahead 1 meter. It's jumping ahead whatever the spacing on the line is. So since I have 1 meter points on the line, it jumps ahead 1 meter at a time as it drives. So anyway, that's what it does. And we could wait for it to come all the way around, but let's go ahead and kill it. We'll kill that one. Now we do the fun stuff. We come back in here and we say path planner, generate points, true pursuit. So we got 2 things here. I want path planner. And this stuff should be made into parameters, so you don't have to come into the code here every time and change it. So in here, I can say turning radius of 2 meters. I still want that 2 meters because I want those loops at the end to still be the same size. But here, instead of a 1 meter step size, make sure my cursor's right, I drop it down to 0.2 meters, which means that it's going to expand the file from like 137 lines.
You
to
put 5.
Good catch. So it's going to generate like 500 points by doing this. It just simply gives you more points in between. So I save that one. And then we come over to the tractor YAML, which is what the Pure Pursuit wants to see. And my wheelbase, that's set up for my vehicle. You know, take a tape measure, measure front to back. It's 0.505. I think Al's is like 1.26 meters. Okay, look ahead distance. This one, if I move this back to say 1 meter. So it's going to look 1 meter in front of the vehicle. That's where it's controlling to. Maximum linear velocity is 1 meter. And steering angle limit, that's 0.785, says plus or minus 45 degrees travel. And this is actually tighter than what my vehicle will do, but as long as I don't push it, that works out fine. So this is basically bigger than what I need it to be. Maximum rotational velocity, I'm not quite sure what to do with that. I just have a number that's greater than what it will attempt to do, so that doesn't affect me. Maybe if you're running the command velocity output, you would want to set a number there to control that. But I just got something. Both of these numbers are bigger. They're not limiting me when the thing is turning. And position tolerance, I have no idea what that is. That might be when you get to the end of the path. That tells it, you know, as you approach the final point, that's how close you got to be. Or I don't know. I don't know what that is. I've never played with that. And then just here's some IDs to make the thing work. So we'll change that. And I think that's all we got to do. See, if I change the tractor YAML, that's it imports that file, imports these parameters. So I have to shut down Pure Pursuit, but see, I've already done that. So I'll run it again. This will get the new parameters in there. And then let's hide some of this crap here. Okay, and then come down here. Well, let me clear some of this stuff out. So right now, before I start it, keep in mind that this is the way Matt's numbers were tracking, and these are actually better than what he showed on his video. And I can't make it as bad as what he had, but anyway, that's the way it was working, and you can see the line spacing there. So I'll come back and clear the odometry, and then I'll clear the path. And now, so I left my vehicle way up here, but that's okay because it will fix itself. So I come here and go. Now, if you'll notice here, hey, that didn't work. Now, let me stop that. I forgot a step here. So let me go back to this thing. I have to regenerate my path after here. Before I do that, let me take a look at it. So by looking at, I can just do this. No, I can't. Well, I can't do that. Zoom. See, if you look at it, keep in mind, this is what the curve looked like. These are the points are 1 meter apart. So you got kind of a lumpy circle on there. So let me clear that. Actually, I don't have to clear it. It'll recreate it. So come here. I have to rerun that one. Since I changed the step size, I have to change that and rerun that again. So now when it comes up, and we go look. See, now the points are close together. Now I get a nice looking curve going around there. And that becomes important because when you're trying to track it, you can watch as that's controlling as the look ahead. Say it starts right here, and before it was going from here, it would jump to there, it would jump to there, it would jump to there. It would follow those segments, the points around on that. And now I've got in between there and there, I've got 5 points now instead of just 1. And the same thing out here. So the points are much closer together. So now I should have a valid path. So let's again start Pure Pursuit. That should be running and publish a path. So you'll notice several things here. Now when the path comes up, you can see the points on the path are much closer together. See all the little purple dots. Now see it's coming down here, and then see it turn. It does a really hard turn. I think that's controlled by that 0.875 I put in. So that's set to 45 degrees. So that's the sharpest I think the vehicle will turn. And you can see now my look ahead is out 1 meter in front instead of 2 meters. And you'll see, because as it drives, you'll see it drives a line from base link, draws a line from base link out to there to control with. And you can see it's staying right on the staying right on the path now. So here, let me turn off the, this is I'm gonna lose my path, but I just want to get rid of those arrows. Drive path. How do I, where did it go? Oh, right there. Arrows, say none. And you can't see it, but now we can see the odometry is leaving behind. See, it's a fairly nice curve there, fairly nice curve. So again, when it first started up, you can see that was a fairly hard turn, and down here it's a fairly hard turn. And at that point, Pure Pursuit was not controlling, and I don't know how it does that, but it's smart enough to figure that out. So let's come back here and kill this, and come down here and just run it again. And I should have cleared the odometry. It's also not running for some reason. That's okay. Clear that, clear the path. So I might have broken it. Publish the path. Let's see, is that running? No, my Pure Pursuit is not running. So I'll start up that. Come down here and start up the publish path. So again, we're going to see it trying to recover, and see it's kind of wobbling back and forth here. So it's not controlling really hard. And if you watch the numbers down here under, say, steering angle, you can see they're bouncing back and forth quite a lot. And see, that time it overshot and does a really hard turn, and then it's controlling. Now we'll start following that. So we'll just watch it come around one of these just to verify, or just to show that really is doing. Let's see, wrong button. But see this line that goes from base link out to the look ahead. It says it's trying to drive to that point. And see, now my lines are right on the curve. So as Al would say, my cross track error is pretty good at this point. And we'll look at the bottom once more, just because. And see, as it comes in, then you'll see it's starting to go to the side, and that would indicate that we're going into a curve. So you could slow the vehicle down there if you want to go hack on the code to make it do that. And the other thing is, we'll say when it gets out to the end, we'll go all the way so you can see what it does when it gets to the end. And it's much more obvious if I speed it up to 2 meters per second, which for me, that's twice as fast as I should be driving. But if I speed up the velocity, then I have to move the look ahead out. So if I have a forward velocity of 2 meters per second and put my look ahead 2 meters out in front of the vehicle, it controls fairly well, but it starts getting a little, you have less control at that point once you do that. So I was just thinking, if we were running at the fast speed, we'd get to the end quicker, so you can see it do that. So while it's driving here, I just touching my microphone. Sorry about that. As it's driving here, any questions or comments or requests?
Very interesting.
Well, it looks fantastic, Jeff. I mean, thanks for digging through that and figuring it out. Do you still have your, what looked like a LibreOffice document where you had your block diagrams?
There it is.
Yeah, so scroll down a little bit if you would.
That one?
No, the execute path.
Okay.
Deal. So that Pure Pursuit, I put a link in the chat. Is that a standard ROS package?
Yes, I think that's the one. Is that the one that says, if you click on it, it says lyrics?
I'll have to go back to it.
Here, I can click on it and see that while things are going on. I think that's what I use. Yes. Now, so one of my side stories that I was going to talk about, it turns out that this puts out an Ackerman command, but when I ran it, it says your Ackerman command does not match the Ackerman command that the gazebo stuff wants, because this is published in an Ackerman command stamped, which means it puts a header and a timestamp on it. And the one that's on the gazebo stuff is just doing Ackerman command without the stamped, which means that the two do not match. So I went through and I thought about that. Well, how am I going to fix this? And here, wait a second. Let me go back. Let me go back. Okay, so I missed the transition I should figure out how to keep it from rotating. That would save a lot of time. But what happens is the vehicle's coming along here. See, this it's off by 1/10 of a meter here because of the problem that Matt had in his code. And when it gets to this point, as it comes around, you'll see the look ahead is going to be out in front. And I think when the look ahead gets to 0, it either disappears or stops there. So the vehicle is now has a shorter and shorter radius, a shorter and shorter control line out to this point. And when it gets here, it just shuts down, and the vehicle just, for some reason, it turns off to the right a little bit and just coasts. It coasts to a stop there. So it's not really lined up. So when I start it again, I'm going to exaggerate this, but as I start it, it's going to make a loop like this until it lines up and runs. In fact, I could just do that right now because so without changing anything else, I'm just run the path again. And you, as I say, if you watch that, you'll see it. See, since it's pointed that way, it'll start driving that way and it'll come like this and then pull itself back in and start working. So if I publish this, and see, it didn't bow out too much, but it did indeed have to do that to correct itself, which it's good that it corrects itself. But if you're planting corn, then your first bit of the row there would be a problem. So the way to get, if you're trying to plant corn and you got this thing all defined, wrong button again. If you're trying to plant corn, what you do is say, like, use the TEB planter and come to this point down here and say, go to this point, point it up, and then start the pure pursuit. And that way it's already going the right direction. So when you hit the line, you're already going the right direction, the right heading, and that should take care of that. So there's lots of little things where we could probably switch back and forth on planners or techniques or whatever to get the stuff to work. So let's see, I was looking at the oh, it's on the wrong thing. But yeah, but back to your question, yes, I believe that's the one right off from the standard one. And it turns out I could have loaded this as the binary, just say sudo apt-get load this file, but I noticed that on Juan's workspace they actually loaded it as the source code. And then in one of those videos where Matt's talking about this stuff, he says, oh, you could load the binary, but we changed it. He said we have a few lines difference, and it looks like the few lines difference was adding that cross-track error that Al's always whining about. And that's the difference on that one. And when I went in there, I started off, I had it there as a text file, and I could have run it just the way it is, but it's complaining that the two messages didn't match. So I foolishly went in and thought, okay, I have to modify one node or the other to make those messages match. And I foolishly modified the pure pursuit. And later I realized what I should have done was just created a separate translator node that subscribes to Ackerman command stamped, reads that in, strips off the header, and just republishes it as Ackerman command. That would keep both ends happy at that point. And that way, once I have that converter, then my stuff that's on Gazebo right now, you could run it either way, either run it with a converter or without, depending. Say if you have a teleop joystick that puts out Ackerman, you could look at that and say, what's it here? Here, this time we can see it. We caught it in time here. So the vehicle is going to come around and see the two lines don't line up. It'll get there, and then all of a sudden it'll kind of drift off to the side as it comes to a stop. So it wasn't quite as exaggerated there. And if you notice down here, it publishes, it's putting out a speed of 0 and a rotational velocity of 0 and a speed of 0 and a steering angle of 0. But those are constantly running right now. It hasn't shut those off yet. So that's something I'm gonna have to fix. So the other thing I was gonna say was, we turn this, we come in here and we say, look ahead, move look ahead out to 2 meters and set steering, let's see, speed, linear velocity, set that to 2 meters. So we'll make it a little more fun here. And I could change the spacing on the path, but I'm going to leave that the way it is. I just want to show you what it does here. So we come here, minimize this, we got that, and I have to shut down this to get it to reload, restart it. This might actually have the what do you call it, dynamic reconfigure might be built into this node. I don't know. It's just that I always just restart the thing. So I'm going to publish this path. Let me back this out. I also notice on here, see the red lines are coming along behind the vehicle. I've got 200 of those that'll show up. So right here, as the thing drives forward, these were disappearing as this is creating new ones over here. So that's why we've got a blank spot here. So I'm just going to leave those, and you can see it as it, you can see it as it drives around. I thought we could get the two paths on top of each other, but no, we can't. So I'm going to publish the path and let it run at the faster speed. See, I don't have to change anything else, right? Right. Let's go there. So now that's in fact, we could even watch this. We could watch it driving around over here. So we come back and we see now it's starting to it's cutting the corners a little more. And I think if you look at it, I think that it's kind of wobbling back and forth too as it drives along here. I guess we can find out by doing this. Yeah, you can see the vehicle's swerving back and forth because it's going faster than what it should be for these numbers. So anyway, that's the effect you get on that stuff. So that I think I'm running out of things to say here, other than as I see, I should have created the translator node to convert one Ackermann command type to the other Ackermann command type, and I need to modify the thing so it stops publishing when the path stops. Oh, the other thing was I was going to say, now we're going faster. We can watch it. Damn it. So it comes around to stop here. It's much more exaggerated now. And see, here's the points disappearing as it comes around. So it's coming like this. It turns out that I guess that marker goes on past, but see, it swerved out quite a bit to the right and drifted quite a ways forward.
Skids to a stop.
Yeah, I don't know if it's actually decelerating or if it's just simply coasting. I think it has to be decelerating because since we're telling a speed of 0, it should be honoring that. So something there's built in probably in the Ackermann controller in the gazebo package is probably controlling that deceleration. So you could have it so it immediately slams to a stop, but that's not really what we're after either, I guess. So anyway, I guess that kind of concludes the presentation here. If there's, I was saying that, what was I saying? Something about that things. Oh, I need to fix it. So over here, it's not publishing this once it comes to a stop. Possibly do the look ahead and decide if you want to slow down for curves. What's the other thing I was going to do? But just various things I was looking at. So once I come over here and keep it from publishing this, then I could actually try firing up both things at the same time. So I could fire up move base and tab planner and then fire this up. And speaking of that, this is something I was going to try that I haven't done yet. So I'll kill this one. And then I will say history grep tab. And if I say run the tab planner at this point without changing anything else, 1835, go. This may fail completely, but we'll see. We'll see what it does here. ODOM received. So if I come back here and as Al would do, I'll say, say I want to do a 2D nav goal to line us back up with this thing. So I want to come to that point in that direction. And you notice it's going to back itself up. I should turn those back on. Well, it's going to back its way into position. And now we're back to the thing is moving really slow for some reason.
Yeah, that's the
Could
kind
that be
of I'm expecting.
the reverse speed?
It actually it is. I think the reverse speed set to like 0.2 meters per second. It's not real bad there, but so anyway, that did indeed work. So now that I turned some of these things back on to see we don't care about cost maps right now. Map. Oh, here it's these that I wanted. And let's just, for the heck of it, say 2D nav goal. Maybe we want to drive over here for some reason. So we can see it, the path planning it's doing. And you can see it's got a lot more resolution than some of the things you might expect. So it'll come there and it'll come to a stop. And then I say, again, set us up back down here. So we'll say, we'll come in right here and say we want to be line it up with our path. And things going to back up. I know people have played with this, but somehow you can set that and say, you know, discourage it from backing up. And sometimes you can maybe do more with it, but I haven't played with this at all. This is basically whatever parameters that were there. Let's put a steering angle of 0.46, which is about halfway to the 0.785 that it could do. So again, that's numbers out in that planner. So now I think if I say shut this down, here, let's clear the odometry in odometry. So clear drive path, clear odometry, turn this back on. I'm not going to change the actual path, but I'll go into, so we kill that. So we put our vehicle where we want it and then come back over to here and we'll say tractor YAML, slows down something reasonable. One look ahead is 1 meter and velocity is 1 meter per second. Save that. Now, if I didn't screw anything up here, I should be able to come back here and say, start pure pursuit. It's out of the way and say here, start the path. So now it should actually hit that at the correct angle since we've gone to the trouble to preset it up. And yep, it comes through pretty close. So it hits the line pretty much where it wants to be. So by taking that extra step, if I could run both of those planners at the same time, I could just, you know, just stop it right now and go up and click a thing says, do a 2D nav goal. And like Al has this set up with the big map of his property, it'd actually be smart enough to plan that path around the house and through gates and whatever. So you could just, you know, transparently, you know, once you get that point stops, then I can say run the fixed one here, and that should work. So that would cover a lot of the situations right there, I think. I was also thinking I just strictly write a Dubin's planner. So I just have a separate node running and you start that and I go up and on RViz say 2D nav goal, it would say, here's the position I want to be, here's where I am. It would then go out and, you know, create a nice smooth Dubin's path between those two. And I could do all that without running move base or move base flex. So it just depends. The advantage of running any of the move base stuff is that you get the maps and the local cost maps and obstacle detection and all that stuff. So it still might be best, you know, to maintain that kind of stuff. So
esoteric question about RViz, because I haven't done anything with it. Are you able to define the robot with I'm going to just call it a movable plow that you can then see what path the plow has been going?
you mean the height of it,
Like if I had
fact that the plow is out in front?
If I had a blade in front of it that I could change the angle of the blade to be able to see what path has been cleared by the blade. Does that am I making sense there?
I mean, you want to see the width of the path as it drives around?
Yeah.
Right offhand, I don't know how to do that. I know that again, back to Ag Open GPS, they've got it where they show their tractor and you pull in, say, a planter behind it, and it actually shows the width of the planter, you know, so as it drives around, it leaves paths behind. But right offhand, I don't know how to do that. And there's all kinds of clever things you can do here to, you know, that you can probably figure something out to make that happen.
Okay.
I would assume, Jeff, that it's related to, if you used inflation to signify the width of that blade, you can probably visualize the inflation that's being presented, but it's probably a number of ways to do it.
Do you want to leave a path behind, or do you just want to see as it's driving to see where it's gone? I'm guessing you'd want to leave a path behind so you can see, you know, are you actually clearing all the snow or not?
Right.
And so again, right offhand, I don't know what it takes to do that, but I'm sure we can figure something out.
Okay.
Your launch file look like for Pure Pursuit? Is it very complicated?
No, it looks like that, which simply says, at one point I was saying, I pulled a Juan stuff and he said he's loading the map server. And I thought, well, why do you want the map server? If you're not running move base, you don't need a map, but it turns out you do have to have that map. So apparently map server doesn't work the way I thought it did. So on any of your launch files, if you say, start the map server and load in a map, if you're running move base, then move base gets that and loads it into the global cost map. But then apparently, you know, RViz must be drawn right off from the map server. And if you don't have this, your links are not connected. So you have to have the map server. And here it says it's using a map of your farm, one of your pastures out there. And I guess we could have looked at that while I was in there. It could be that was in there as a map. I didn't even think to look for that. It's just that we happen to be out in the middle of it, I think. So it says, start the map server. It just maps the ODOM on top of map, you know, just a static transform. And then I don't know what this is used for, unless that's a name, or it's his name, that may be a namespace. So when you go look at it, you say ROS topic list, you might say these topics are under that name. And then otherwise, here's it says start Pure Pursuit. It loads in three different, it loads in two links, and then loads in I guess they're all three of them are frame IDs, loads in 3 frame IDs, and then immediately loads in the tractor YAML, which overwrites those. So you know, technically you could delete 3 of the lines out of here. And then down here, just the other things just to make it work. So that's all it takes to get that to run right there.
Yeah, I'm forgetting what sort of errors I was getting when I was trying to get that running. I'm not sure I ever got cat can make to work correctly on the C++ code.
Well, that might have been because you had dependencies missing or something, might have been what your problem was, but I don't know. Mine seems to compile, and I might have had a couple of problems, but I just looked at it and said, oh, I do this to fix them, and maybe that's all it took. So.
And then he had some code in there about got path, and it was like I couldn't figure out where that was getting published from.
Oh, he had some other weird stuff there. He's trying to add some handshaking. So instead of manually doing stuff like I was just doing, he was trying to get it to the point where you could start it and the 2 programs would talk to each other. And I think he screwed that up too. So that might be let's see, how do I get to chat from here? So again, I lost my Zoom window. Zoom. Maybe it's under here. Okay, chat. And go. So there are some links to, as I said, there are the ROS agriculture videos, and I don't remember, it says, so the first one says quick mention. He just simply said, we created, that might be the one where he said, we're creating a Pure Pursuit planner and we're thinking about running it with move base, just so you can drive from your barn out to your field and then turn it over to the Pure Pursuit. And then the other 2 down there are actual, he's running his video, that screenshot I had, he's got a video of that running, and he explains some things. And one of those 2 is where he's talking about the cross-track error showing up on that number on RViz. So you can go watch those, and they they run better, you know, rather than me trying to run the video here and record it through Zoom because that it'll be all choppy. So that's what I had there. I was trying to think if I had anything else I was going to put out in the chat. I could always add it later, but if I mention it now. So this thing, one thing am I still sharing? Let's see.
Yep,
Other
you're still
fun
sharing
stuff.
that.
I gotta get it so I can see it here. See that coming here. Oh, I can't delete that because that's the shared screen. I can't delete it. So yes, and the other things to note here, he's got this this one right here, this ODOM to path pi. That's the program. Do I have that open? This is the one that will it tracks your odometry point and builds a path out of that and publishes it. And that's how he's getting his green path to show up. I was using the little red arrows, but he had on it when he runs his, he gets an actual line of where the thing drove. So that's how he's doing that. And then the other thing was this RViz display pi. That's the intermediate Python program that takes the path error that's being published by the modified pure pursuit, and it reads that in and republishes it so that the indicator on RViz can display that. So it's just a little intermediate utility that's running. One other thing I wanted to mention, how many hours over are we? Oh, we're way over. So if I go look at this ACNU Zacro, I'll show you where I was having the problems. So if you go into your the Zacro file for the URDF, and it's defining the vehicle itself under right steering joint. See right here, it says right steering joint. Under that, it has a revolute joint. You can either have a continuous or a revolute, and that's a you know, you got a joint that can turn like this is what that's a rotary joint. If you put a continuous, it can just, you know, like on your wheels, you put a continuous joint, but on something like steering or something else, you put a revolute joint, and that you can define a minimum and a maximum angle that can turn at. So that's how they're doing the steering. And down here, originally it said on this line here, it said the effort of how much it can turn and how fast it turns, but it said set the lower and the upper limit to 0.785. So that's saying it limits the steering to plus minus 45 degrees. And when I built my tractor, I thought, well, mine can't turn that sharp. So I put in this line. Here, let's do it this way. I put in this line that says lower and upper are 0.52, and that converts to about 30 degrees. So mine can turn plus minus 30 degrees. But it turns out when I put it into Gazebo and running the pure pursuit, it was trying to turn slightly sharper than that and it wouldn't stay on the line. So I just simply opened it back up. And what I did was I took this line and copied it and put the 0.785 in. I could have just uncommented this line here. I could have just uncommented that and then commented this line out, and that would have fixed it. So that's something you might want to do one of these days, is go into the ACNU Zacro and search for right steering joint, and then swap those two lines around. So you're using the bigger angle, and that way that'll work out better for you. And other than that,
I'll definitely go look at that.
So I'm now running out of things to do here.
Well, before you get off, can I share my screen for a second?
Okay, let me see if I can figure out how this works. If I say under Linux, you got to say new share. Okay, as soon as I do that, and then you have to say cancel. Not now. Okay.
So this is, I think, where I was getting hung up. This is that publisher, path publisher. So my assumption is this was going into yeah, this is output that goes into pure pursuit.
Pure
Did
Pursuit
you,
or Tab Planner.
Pure Pursuit?
Okay.
I mean, this was the one that subscribes to GotPath and publishes DrivePath. And then in the launch file that you showed, you remapped that a little bit. This is where I was couldn't figure out this GotPath thing.
Well, that's
You
because it doesn't make sense. He was trying to do something that the way his publisher was set up, it would publish it, and then every 5 seconds it'd publish it again and again and again. So to get around that, he had this thing about got path. So he would publish the path, and then I think Pure Pursuit, he modified that in. So then when it was done, it would publish on got path. So he's trying to get the two to work together, and that. So basically, I think I basically took that stuff out. I just went down to the bottom where it said something about every 5 seconds publish. I just had a thing that said, instead of doing it every 5 seconds, I said publish the path. And it turns out there's another problem. If you publish the path, it doesn't work. You have to publish it a second time, and then it works. So I had it so it said publish path, wait 1 second, publish path, wait 1 second, and then exit program, I think is what I did. And so I cheated on that. I just hacked on that till I got it to do something.
got it. Thanks.
I don't know if that makes sense or not, but that's what I ended up doing. And I wasn't beyond taking liberties on this just to get it to work, because I figured, once I get it figured out, then we can figure out a better way to do it. So.
Well, it looks great what you've got.
And back to the question that people always say, well, what's it take to switch between a simulated vehicle and a real vehicle? Well, again, as long as your topics between the two match, I should just be able to say, drive it in simulation and then kill the simulator and then start up my node that talks to my vehicle. And it should magically actually drive around the yard or out in the field the same way. I think that's the intent anyway.
Just some hand waving and magic dust and it all works.
Yeah, that's
Hocus pocus, alakazam.
Well, it is pretty cool to at least see it in simulation and have the URDF working and have the ODOM published. I mean, it's all, I think, pretty awesome at this point.
And just not to change the conversation, but I was also thinking, well, we should fire up ROS 2 and use that navigation. But I remember when I was the main thing I couldn't get to work, with the stuff I'm doing now, I couldn't make that ODOM publisher work under ROS 2, because the way it works, it magically goes into Gazebo and pulls some kind of position stuff out. And that doesn't exist under the ROS 2 version, if I recall. But if we would go back and take the published GPS and run it through the GPS to ODOM, like works on a real vehicle, that would get around that problem. So technically, we could have the newer navigation with all the fancy bells and whistles and then still run that and get it to work. But that'd be a matter of switching over to ROS 2, and that's, more screwing around to do that. So you have to relearn a bunch of stuff, and, somebody's got to make it work in the first place. So that's just
So
another.
would you recommend that I not learn ROS 2 yet?
You
I don't know
ROS.
ROS 1 yet.
The point is, if you're trying to learn both of them, probably trying to learn both at the same time is not a good idea, because they're enough different that then you'll have no idea which way is right and which way is going to work and not work. So if you're willing to charge ahead into ROS 2 and figure all that out, feel free. But at the moment we're still running everything under ROS 1.
Okay.
Therefore, we could answer your questions if you're staying in ROS 1. If you want to switch to ROS 2, you can get on the Homebrew Robotics meeting on Tuesday nights, because they're running ROS 2, and they say that's an open meeting for anything ROS. So technically, you can ask those people, and people on there that are smart enough and use ROS too. They could answer questions there, but for the moment, I would say, all things considered, I would say you should stay on ROS 1 right now because that's what we are using.
Okay,
Oh, let me save the chat so I don't lose that. I was trying to think I was thinking there's some other things I was going to post to chat, but now I can't think of what they were. Save chat. Okay.
I imagine I've got now a foot of snow outside that I need to clear out, so
Well, I got mine cleared before the meeting today, and it's, you know,
I didn't.
I got another inch or so down, so I got to go clean it up. I didn't get it all the way out the edge of the sidewalk. So are we done with real stuff?
Yes, I believe so.